Have you ever seen a rainbow pattern that looks like this? It's actually made by our own sun, just a little bit differently to the rainbows we see in the sky. Let's have a look. I have a box here with two thin slits at the top where sunlight is entering through. So what would be at the bottom? Well, if you think there would be two stripes of sunlight, that's a pretty good guess. But that would be assuming that light interferes like a particle when it actually interacts with these slits as a wave. What we perceive as light is actually the propagation of waves, which means a single light wave oscillates above and below its baseline, like this. This can be shown through wavefronts, with the crest being the highest point above baseline and the trough being the lowest point below baseline. When light isn't obstructive, it moves in a straight, predictable pattern like this. But when it is obstructed with two slits, the points on the wave which pass through form a new wavefront. Since they have the same wavelength, the crests and the troughs align, which means that the waves are in phase with each other. That's an example of wave interference. Constructive interference is when the maximum point of a wave above or below baseline overlaps with the same point on another wave. The bright spots show where constructive interference is happening. This is called diffraction. I made my own diffraction grating here, and as you can see, there's an alternating pattern of bright light and white spots. It looks like the rainbow pattern we saw before, but where does the actual rainbow come from? Sunlight has multiple different colours, which means that each colour can only interact with wavelengths of that same colour. For example, red light has longer wavelengths, so the red light appears to be on the outside of the bright spot in our diffraction grating. Violet light, on the other hand, is much shorter, and so the violet light appears to be on the inside of the bright spots. So, all types of light interaction are caused by the points above and below the baseline of a light wave.